In this video, we're going to explore the techniques that we can use to figure out how many choices there are in a given scenario. So, when we find the probability of any event occurring, we usually try to figure out how many outcomes are there where the event occurs, and then divide through by the total number of possible outcomes in that given scenario. Counting methods helps us find both of those things. This video specifically will cover two main concepts. One being the addition rule, which is used for calculating the number of choices in mutually exclusive events, and the multiplication rule, which is used for calculating the number of choices that are made in sequence. And then, after that, we're just going to look at how to apply those principles to the exam-style questions that you'll come across. For those that don't know me, my name is Chris Ionizone. I used to work as an engineer for a defence company, and I left that to start a career in tutoring. I make these videos to help VCE students do the best they can in math methods. Well, with that out of the way, let's get started. So, what do I mean by mutually exclusive choices? Well, let's consider the case where we're at a restaurant that's serving a set menu. And on that set menu, there are 2 choices for entree, 2 choices for main, and 3 choices for dessert. The choices within each course are mutually exclusive. Within each given course, you cannot choose more than one option. For example, you could have either a steak or a pasta dish for main, but not both at the same time. These are mutually exclusive choices. This is the type of scenario where the addition principle applies. If you can only make one choice out of a set of groups, then the total number of possible choices you could make is just the addition of all choices within those groups. Sometimes exam questions will just sort of dress it up a little bit to make it look different, but really the underlying math is the same sort of thing. So let's suppose we're in a different scenario where we're trying to select our final subject for Year 11. And let's suppose we can only choose one of 4 sciences, 3 maths, and 5 humanities. We can only make one choice. So our total number of possible choices is just the sum of all the individual subjects. At the end of the day, we can only make one choice. So it doesn't matter that we've called them a math or a science or a humanity. You're still just picking from a group of 12 total possible subjects. When choices are made in sequence, the multiplication principle applies. Let's consider another scenario where you're going to the gym. Well, to go to the gym, you have a couple of different options for commute. You could either walk to the gym or you could drive to the gym. And then, once you're there, you can choose to do either cardio or weights. These are choices made in sequence, so the multiplication principle will apply. The total number of choices for this given scenario is calculated by multiplying the number of choices in the first stage by the number of choices in the second stage. So we had 2 options for commute in the first stage, and we had 2 options for exercise in the second stage. 2 by 2 gives you 4. A tree diagram can also be helpful for visualizing this, but it's only really useful for the smaller types of experiments. As soon as the number of choices in each stage increases, it becomes very impractical very quickly. And so, the remainder of this video is just going to be looking at how we can apply these principles to the exam style questions. This one here is another restaurant example, but it's got a bit of a twist to it. We're told there are 4 entrees, 5 mains, and 2 desserts. The question then asks us to find the total number of possible meals if we can omit the entree. There's actually a couple of ways we could approach this, and the first is to consider the choice of removing an entree to itself be a choice of entree. That gives you 4 possible meals for entree, and an additional choice of removing that entree. These are choices made in sequence, so the multiplication principle is going to apply. There's 5 choices for entree, multiplied by the 5 choices for main, and then again multiplied by the 2 choices for dessert. The second option is to split the scenario into 2 different groups. The first group will consider what happens if we include an entree. So that's 4 choices for entree, 5 for main, and 2 for dessert. Then we're going to add that to the number of choices that don't include an entree. That means we have 5 choices for main and 2 choices for dessert. The reason we're going to add these 2 scenarios together is because they are mutually exclusive events. You cannot both choose to have an entree and not have an entree at the same time. Whenever you have mutually exclusive events, they add together. A company uses 4-digit product codes to track its various items. The first 2 digits must be letters, and the last 2 digits must be numbers. How many possible product codes are there? This is an example of choices made in sequence. There are 26 choices for the first digit and 26 choices for the second digit, since there's 26 letters in our alphabet. And there's going to be 10 choices for the third digit and 10 choices for the fourth digit, because again, we have 10 numbers from 0 to 9. All we do here is multiply them all together, because they're choices made in sequence, and we're just going to get a nasty big number. What if we wanted to find the total number of product codes that end in an even number? Well, this is still choices made in sequence, but the additional restriction that it has to be an even number at the end means we have to be very selective in how many choices there are for each digit. We typically start by addressing the restriction. In this case, we're looking for what is it exactly that makes a number even. And as far as we care, even numbers are just numbers that end in either 0, 2, 4, 6, or 8. So that gives us a total of 5 possible choices for that last digit. From here, the rest of the question is the same. There's still going to be 26 choices for the first and second digits, and 10 choices for the third digit, since that third digit doesn't really have any impact on it being an even number or not. And once again, you're just going to multiply across, because all the choices are made in sequence. And finally, we're going to apply it to probability. What is the probability that our product code ends in an even number? Well, if you want to find the probability of any event occurring, you find the total number of times that event occurs and divide through by the total number of possible events that could have occurred. Well, we found the total number of possible product combinations in the first section, and then in the second section, we found the number of those that were even. So all we're going to do is divide the second by the first, and that's going to come out to be a half, which makes sense considering that half of all numbers should be even. Suppose we have a desk that has 3 customizable options. There are m total options for the desk material, there's a quarter of m choices for the desk size, and there are 2m choices for the additional accessories. Again, this is an example of choices that are made in sequence, and so the number of choices in each stage are going to multiply together. The interesting part of this question is that we're told that the total number of possible choices is greater than 600, and we have to use this information to figure out the smallest possible value of m. Well, we've already created an expression for the total number of choices with that variable. All we need to do is include that inequality greater than 600. And this we're going to solve using the CAS. The TI Nspire and the Casio ClassPad have the same syntax as described here. Well, this gives us a decimal answer, but it doesn't really make sense to have a fractional number of choices, so usually we would just round that up to 11 and call it a day. But that doesn't actually avoid having a fractional number of choices. There are a quarter of m choices for the desk size, and if you choose 11, well, that's going to give you 11 over 4 choices for desk size. That's still a fraction. So what we're going to do is round that up to the nearest number again, which is going to be 12. That would give 12 choices for desk material, 3 choices for desk size, and 24 additional accessories. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge, so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.